So, have you ever really stopped to think about how information gets around on the internet? It's kind of like this massive global postal service, and it uses two totally different methods to deliver every single piece of data you send and receive. Today, we're going to unpack those two methods, TCP and UDP.
I mean, think about it for a second. You've got a browser open, you're streaming some music, maybe you're in an online game. When all that data hits your computer, it's not just addressed to your device. It has to find its way to the exact application that asked for it. So how on earth does your computer sort all of this digital mail?
Well, the magic happens in a crucial part of the network called the transport layer. You can think of it as the internet's internal mailroom. See, other layers get the package to the right building, that's your computer, but the transport layer makes sure it gets delivered to the right person, or, in our case, the right application. This is what we call process-to-process delivery.
And, this mailroom gives you two totally different shipping options. On one hand, you've got TCP. This is your premium tracked parcel service. It's all about reliability, confirmation, the whole 9 yards. And on the other hand, you've got UDP, which is way more like a postcard. You just drop it in the mail and hope it gets there. It's fast, but there are absolutely no guarantees. So, let's figure out why you'd ever need both. All right, let's dive into the first one. TCP, which stands for Transmission Control Protocol. This is the internet's most meticulous, most dependable career. TCP is basically built on a series of promises. First, it's connection-oriented, which means it actually sets up a dedicated line of communication before a single piece of data is sent. It's also super reliable. It guarantees every single byte arrives and arrives in the correct order. And finally, it manages both flow control, so it doesn't overwhelm the receiver, and error control to fix any mistakes along the way. So what does connection-oriented actually mean? Well, TCP does this thing called a three-way handshake. It's basically like making a quick phone call to confirm the delivery details. The sender shoots over a SYN packet, which is like saying, "Hey, you there? I've got something for you." The receiver responds with a SYN ACK, saying, "Yep, I'm here and ready to go." And finally, the sender sends one last ACK to say, "Awesome, the data's on its way. Now the connection is live." Okay, so how does TCP keep all of these promises? It all comes down to its incredibly detailed paperwork. Every single TCP packet has this big header attached to it. Just think of it as a super detailed shipping label that has all the info needed to track, order, and confirm the entire delivery. So first up in that header, the port numbers. If an IP address is the street address for the building, the port number is the specific apartment number. This is what tells the transport layer exactly which application's door to knock on. It's how your web traffic finds your browser, and not, say, your email app. Next is the sequence number, and this is where TCP gets wildly specific. It doesn't just number the packets. No, it numbers every single byte of data it sends out. This is what allows the receiver to reassemble the entire data stream perfectly in the exact original order, even if the packets themselves show up all jumbled. Now, to confirm that all those bytes are arriving safely, the receiver uses the acknowledgement number. This is literally the delivery confirmation part of the service. The receiver uses this to tell the sender, "Okay, I've received everything up to byte 5000. Please send me byte 5001 next." If the sender doesn't get that confirmation, it knows something got lost and just sends it again. Simple as that. And what about that flow control? For that, we have the window size field. This is how the receiver can tell the sender how much mailbox space it has left in its buffer. It's like shouting back, "Hey, slow down, I only have room for about 2,000 more bytes right now." This is what prevents the sender from just flooding the receiver with data it can't handle. Okay, so we've seen the super reliable, maybe a little obsessive TCP. Now let's talk about its complete opposite, the User Datagram Protocol, or UDP. If TCP is that tracked parcel, UDP is like dropping a postcard in the mailbox and just walking away. UDP basically throws every single one of TCP's rules right out the window. It's connectionless. It just fires off data with no handshake, no hello, nothing. It's what we call unreliable, because there's no guarantee the data will arrive or that it will arrive in order. But its huge advantage is its tiny overhead and just raw speed. And just look at the difference in the paperwork. The UDP header is minuscule. It's a fixed 8 bytes, that's it. Compare that to TCP's much bigger, more complex header. All UDP cares about are the port numbers, the packet length, and a really basic optional error check. That's the whole shebang. No acknowledgements, no sequence numbers. It's lean, it's mean, and it is built for one thing: speed. So you gotta be asking yourself, right? Why on earth would anyone choose the unreliable postcard over the guaranteed parcel? Well, the answer comes down to one very simple, very important thing. Speed. That's it. For some applications, getting data a millisecond faster is way more important than getting every single piece perfectly. Think about it. In a live video stream or an online game, an old packet that got lost and had to be resent is useless. It's already ancient history. It's better to just drop a single corrupted pixel and get the very next frame immediately. A tiny little imperfection is a totally worthy trade-off for a smooth, real-time experience.
So here it is, the final showdown. TCP, our tracked parcel, gives you that high reliability, but it's a bit slower because of all its safety checks. It's perfect for things where every bit of data is absolutely critical, like loading a web page or sending an email. Then you have UDP, the postcard. It's way faster but offers a best effort delivery. This makes it the champion for real-time stuff like online gaming, voice calls, and video streaming, where speed is king and a lost packet here or there is no big deal.
So the next time you're online, you'll know exactly what's going on under the hood. When you're loading a web page, your computer is sending and receiving a bunch of carefully tracked parcels. Hopping into a video call, you're firing off a stream of super fast postcards. Each one is a tool, perfectly suited for its job, and they both work together to build the internet we use every single day. Thanks for joining this explainer.